All right. So now I am going to be doing a video on analyzing quadratic functions. This is an Algebra 1 video, okay? So today we're going to be analyzing quadratic functions. And as we analyze this is a topic we've already known how to do. We're going to be talking about function transformation, okay? So in recalling function transformation, I need to recognize that the parent function of the quadratic family is f of x equals x squared. And let's go ahead and just do a quick little sketch of what f of x equals x squared looks like. So if I recognize it, f of 0, 0 squared is going to give me 0. F of 1, 1 squared is going to give me 1. F of negative 1, negative 1 squared is still positive 1. 2 is going to give me 4. Negative 2 is going to give me 4. So here is my function right there, okay? Now, I'm going to also graph 3 other functions just so we recognize what's happening here. So I'm going to graph g of x, which is x squared plus 3. I'm going to also graph h of x, which is x squared minus 3. And I'm going to graph, let me find another color. Here we go. We'll call it m of x is equal to x plus 3 squared. And then I'm going to also do one more, and that's going to be n of x, which is x minus 3 squared. Okay? So the very first thing I'm going to do is I'm going to start with a little table of values for each of these. So let's see. And I'm just going to go negative 2, negative 1, 0, 1, and 2 for this guy. So let's try with negative 2. Negative 2 squared is 4, because negative 2 times negative 2 is positive 4, plus 3 gives me 7. Negative 1 squared is 1, plus 3 gives me 4. 0 squared is 0, plus 3 gives me 3. 1 squared plus 3 gives me 4. And 2 squared plus 3 gives me 7. So if I recognize, I'm going to do a quick little sketch here. 0, 3, 1, 2, 3, right there. 1, 1, 4, negative 1, 4, and 2, 7, right there. So if I graph it, we recognize, and then I'm also going to still graph my parent function right there. What happened here? This was a vertical translation 3 units up. So remember, it's outside of the parentheses, so it's 3 units up. What do you think this one's going to be? This right here is going to be a vertical translation 3 units down. So without even doing a table of values, I can say, well, 0 squared minus 3 is negative 3, right there. 1 minus 3 is negative 2. Negative 1 minus 3 is negative 1 squared minus 3 is negative 2. And let's see, 2 squared, 4 minus 3 is 1. So notice that my function over here against this one, so the g of x, this is g of x right here, and this one's h of x, and this one's f of x. We can see that g of x is the parent function shifted 3 units up, and h of x is the parent function shifted 3 units down. So now let's look at this one here. Let's go ahead and look at that one. And for that one, notice it's inside parentheses. So this should bring you back to when we were translating exponential functions. So let's see. I'm going to negative 5, -4, -3, -2, -1. So let's see. -5 plus 3. -5 plus 3 gives me -2. -2 squared is 4. -4 plus 3 gives me -1. -1 squared is 1. -3 plus 3 is 0. 0 squared is 0. -2 plus 3 is 1. 1 squared is 1. And -1 plus 3 gives me 2. 2 squared is 4. Okay, so let's see what this graph looks like. Okay. 1, 2, 4, -2, -4. Okay. So as always, I'm going to still graph my parent function. Here's my parent function. This is still f of x. That's my parent function. I'm going to graph now m of x. Right here, let's see. -5, 4, -4, 1, -3, 0. And it's right there. So let's see. Here is my function. And what do you notice? From the comparison here, I notice that this is now horizontal translation. How many units in what direction? Horizontal translation, 3 units left. Remember what's the rule? Input analysis inside the parentheses is always opposite of what the equation tells you. My equation is telling me +3, which really means 3 units to the left. So let's look at this one now. What do you think this one's going to give me? So let's see x and n of x. I'm going to go for this one. I'm going to go 1, 2, 3, 4, 5. And let's see. 1 minus 3 gives me -2. -2 squared gives me 4. 2 minus 3 gives me -1. -1 squared is 1. 3 minus 3 is 0. 0 squared is 0. 4 minus 3 is 1. 1 squared is 1. And 5 minus 3 is 2. 2 squared is 4. Okay, so now I'm going to do this one here. Let's see what we get. I got 1, 4, 2, 1, 3, 0, 4, 1, and 5, 4. Oops, sorry, right there. So here's my function. And what do you think this one is? Horizontal translation, 3 units right. Again, opposite of what the equation is telling you. I hope this reminded us of function transformations when we looked at them from exponentials, okay? So this takes us now to why it's so important to be able to recognize vertex form, but I'm going to do another little thing on reflections, and this is really important. So let's I have f of x, my parent function is x squared, but now this time I'm going to say g of x is -x squared. Oh, that's important right there. So let's go ahead and see what that graph looks like. So again, I'm going to graph my parent function in blue, 0, 0, 1, 1, 2, 4. So here's my parent function, that's f of x. But now I'm going to do g of x. Let's see. So g of x means, let's see, -3, -2, -1, 0, 1, 2, 3. Okay, so -3 squared, notice this means -x squared. So I try the input first, and then I apply a -1 coefficient multiplier on it. So -3 squared is 9 times -1 is -9. -2 squared is 4 times -1 is -4. -1 squared is 1 times -1 is -1. 0 has no value, so it's still 0. No sign, I meant. 1 squared is 1 times -1 is -1. 2 squared is 4 times -1 is -4. And 3 squared is 9 times -1 is -9. So this indicates to me, let's see, 0, 0 still there, but now I have 1, -1, -1, -1. I have 2, -4, -2, -4, and so forth. So here is my parabola now. What do you notice? So this right here is indicating that little thing right there indicates a reflection against what? The x-axis. And it's also letting me know that A is equal to -1, which understands that the concavity is down, okay? So that's important. Now let's look at this one here. It's already reflecting on the y-axis, right? So I'm going to show you how. Let's say I have h of x is equal to f of -x. Let's see what that gives me. So that means I have -x squared. Notice that's my parent function. All I did is I replaced the x with a -x, and I still get that. What's -x times -x? It still gives me x squared. So if I look at those values, -2, -1, 0, 1, 2. -2 becomes +2. 2 squared gives me 4. -1 becomes +1. 1 squared gives me 1. 0 doesn't matter because it doesn't have a sign. 1 becomes -1. -1 squared is 1. 2 becomes -2. -2 is still 4. It's still the same function as my parent function. Here's my parent function. Bum, bum. And right there, here's my parent function. That's f of x. And now let's graph the next one. -2, 4. -1, 1, 0, 1, 1. If you notice, they are equivalent because my parent function already has the symmetry against the y-axis. But I did want to showcase how that right there, if I have, let's say I have a, where's my marker? H of x equals -x squared. Inside if the negative coefficient marker like that, like you see right here, it's outside of the parentheses, means it's going to affect the outputs. If it's inside, it's only going to affect the inputs, and if there's no other translation, the symmetry is y-axis right there, okay? So moving on, let's look at horizontal stretch and horizontal compressions. Okay. So what does this mean? Again, I'm going to begin with my parent function, x squared. And I'm going to also graph, let's see, g of x is equal to 1/2 x squared. And I'm going to graph h of x is equal to 2x squared. So here, I'm changing my a value. So as I'm graphing this, we'll see right now what happens. Okay. So as always, I'm going to put my parent function first. 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. Here is my parent function. That is f of x. That's the parent function. Now let's see what happens with g of x. So here, let's look at a table of values with g of x. And I'm going to go -4, -2, 0, 2, and 4. So let's see. 0, 1/2 times 0 squared is still 0. -2. -2 squared is 4. Half of 4 is 2. -4 squared is 16. Half of 16 is 8. 2 squared is 4. Half of 4 is 2. And 4 squared is 16. Half of 16 is 8. So let's see what we get. I have -2, 2. 0, 0, 2, 2. And then I have -4, 8. 4, 6, 8 right here. And 2, 4, 6, 8 right here. So notice my parabola widened up. It widened up, okay? Now let's look at the other one. Let's look at h of x. So I'm gonna just use negative 2, negative 1, 0, 1, and 2. Okay, so let's see, 0 squared, 0 times 2, 0 still. 1 squared is 1 times 2 is 2. Negative 1 squared is 1 times 2 is 2. Negative 2 squared is 4 times 2 is 8. Notice now. And then 2 squared times 2 is 8. So notice that these values, the outputs are the same, but this happened in a matter of from negative 4. Let's see, negative 2, 0, 2, and 4. It happened in that span versus this happening only from this span. So notice, right? The span of these outputs happening went from negative 4 to 4. And now this one, we'll see what happens. So I have negative 2, negative 2, 8. I have negative 1, 2, 0, 0, 1, 2, and 2, 8. So now this parabola, noticed, is a lot thinner, while the other one is wider. So this 1/2 right here gave me a horizontal stretch because my parabola went from being like that to wider. And this guy here gave me a horizontal compression, which means my parabola, that's my parent function, went from that to much thinner, okay? So that's something we need to make sure we recognize. So let's give a little example. Explain, because your homework is going to have this. Explain the transformation. And so the first example I'm going to give you, it's going to say g of x is equal to negative 2x plus 4 squared minus 7. So let's see. What information can I get from here? So it's negative 2. This has two different things. It has a reflection on x-axis because of the negative. It also has a horizontal compression. Because so when A is greater than 0, it's compression. It's a stretch if it's between 0 and 1. Okay? And then I do have a translation for to the left. Remember, inside of the parentheses is always opposite of what the equation tells you. Outside is always going to be literal. And a translation 7 units down. Okay? So if I'm going to graph this, if I want to graph this, and I'm going to graph the parent function too so you can see what I'm doing. Just making some more space. Okay, I'm still going to graph my parent function so you understand. Here's my parent function. There's my parent function. But now I'm going to graph my other function. Let's see if I can graph it in a different color. Okay. So we recognize that that vertex went 4 to the left, and 7 down. Bloop, bloop, bloop. So I know that. I also know that it reflected. So it reflected like it reflected like this, and then it traveled 4 to the left and 7 down. But it also has a compression. So now that function is going to be compressed. Instead of opening up like this, it's now opening down, and it's going to be compressed. So notice, just by this information, I was able to graph that function right there, just like that. Okay? Now, let's talk about analyzing quadratic equations by information that they give you. So, in your homework, you're going to be asked to give me the equation of a quadratic equation in a specific format when I give you just the vertex or a 0 or the y-intercept or something, and a point it passes through. So what happens here is the point that you pass through is going to determine your a. Okay, so let's look at this equation. So I'm going to ask you, find the equation of the quadratic function with a vertex at 1, -2 that passes through the point 0, 1. Okay, so let's look at what we know. We know it's a vertex of 1, -2, and then this is the point it passes through. So we're going to go ahead and see what we can do. I'm going to need to know the vertex, so I know we're going to start with vertex form. So vertex form is what I'm starting with because that's how it's given to me. If it was given to me with zeros, I'll show you that example after. You're going to be able to start with vertex form. Factored form. So vertex form looks like this. F of x is equal to a x minus h squared plus k, where the vertex is in the format hk. Okay, so I know my vertex is -1, -2. +1, my bad. +1, -2, which means that's my h, that's my k. So given this, I'm going to plug that in now, okay? I also know a point. The point I know is 0, 1. So this is x and f of x. So I'm going to put all of this information in. I know my h is 1, my k is -2, my x is 0, and my f of x is 1. So that's all I'm doing is I'm now going to plug in all of that information into that equation. So I have 1 equals a 0 minus 1 squared minus 2. Again, f of x is 1. Notice my fingers here. Look at bloop, bloop. A, I don't know. X is 0. H is 1. Minus, my equation says minus, so that 1 stays right there as -1. Opposite of what the equation tells you right there. And my k is -2. Now I'm going to simplify this so I can solve for a. 1 is equal to a -1 squared minus 2. So all I did is I simplified the parentheses using PEMDAS. I'm still using the p. Now I'm going to simplify the exponent, -1. Okay, now I'm going to multiply a times 1. So this gives me 1 equals a minus 2. Now I get to move that -2 over by adding 2 to both sides. I recognize that my a is 3. And this is important because in the information, you already knew what the h and k was. You just didn't know what a is. And so if I want to finalize this, the equation is f of x is 3. X minus 1 squared minus 2. This is my equation right there. Okay? And my last one, let me give you one more example. Again, I'm available for office every single day. You just have to reach out to me. Find the equation of the quadratic function that has zeros at x equals -4 and x equals 0 and passes through the point -3 and 6. Okay, so let's look at what we know. We know it has zeros, big right there. Those are my zeros. And it also passes through this point. So now the format I'm going to be using here is not going to be vertex form. Here, the format I'm going to be looking at is factored form, because factored form showcases the zeros. So here, it'd be f of x is equal to a x minus r1 times x minus r2. So let's look at this, right? R1 is going to be -4, and R2 is going to be 0. And I have a point, -3 and 6, which this point right here is always going to be my x and my f of x. Okay? So let's go ahead and plug everything in. So let's see. What's my f of x? 6. 6 is equal to a. I don't know what that is. My x is -3. -3 minus -4. Notice I put minus -4. That's a big one. Okay? And then I have -3 minus 0. Okay, first thing I'm going to do is I have to do the 2-line rule on that minus situation, which means 1 line, 2 lines. So that's going to give me 6 is equal to a. -3 plus 4 gives me 1. And -3 minus 0 gives me -3. Okay? I'm going to multiply that. That gives me 6 is equal to -3a. So -3 times 1 is -3. -3 times a is -3a. I'm now going to solve for a, which means I divide both sides by -3. A is equal to -2. So my function equation here is going to be f of x equals -2 x plus 4 times x minus 0. Remember, opposite of what the equation tells you, and it's because of that minus 4, okay? So here, I'm going to leave my equation in factored form because it's asking for zeros and a point. But that point is allowing us to understand that that function has a downward concavity because it's a -2 as my a, okay? Hope you enjoyed this video. Enjoy your day. Ask me questions. I'm here for you guys. You.